guys. Welcome to day 2 of Python Conference Indonesia 2021. And now with me, Nita, as your moderator, and in backstage we have Melissa as our co-moderator. Now, in this talk, we have Kamal Mustafa, or Mas Kamal.
Hi.
Halo Mas Kamal.
Hi.
Nice to see you.
Okay, nice to meet you too.
Okay, he is a CTO from Laloka Labs. I will read a short profile about you. Okay? He is a web development enthusiast since 2000. He's been full stack developer starting with ASP, then PHP. Wow. Now focusing in Python and Django. Loves sharing technical knowledge and insight through blogs and community outreach. Wow. Do you have blog?
Yes.
So good. Okay. Title of talk is Build multi-tenant task keys using PostgreSQL and Python, right? Hello, Kamal.
Yeah, I think I missed that. Are you asking something?
No, I just
You,
read your title of talk.
okay. The connection is kind of being a
Uh-huh.
bit jitter.
Okay.
Yeah.
So we will start your talk, but for participants, you can drop your questions on below platform because we will take them and discuss it in Q&A session later. Okay.
Okay. I'm supposed to start now.
Thank yes. Yes, please enjoy the talk.
Okay. Thank you. I'm sorry because I think the connection is lagging here, so I kind of miss some of the audio from here. But okay. Anyway, thank you to Nita. And good afternoon everyone. Selamat siang buat teman-teman di Indonesia. Terima kasih kerana bagi peluang untuk saya turut sama dalam conference PyCon Indonesia pada kali ini. Sayang sekali kita tidak bisa ketemu di alam nyata kali ini. Aku memangnya kepingin sekali untuk ke Indonesia buat kali kedua. Tapi ya terpaksa dengan melalui online saja. Okay. Okay, before we proceed, I think let me introduce myself first. I'm a professional web developer, currently as CTO at Laloka Labs, where we built an OTP API named Get OTP, and it allows you to add OTP features to your application without having to implement all the OTP flow and UI. And while at Zoxo, we built a telephony API, which consists API to send and receive SMS, make and receive phone calls, and some other stuff. We are fully remote company starting since 2007, and I myself have been working remotely since 2010. So this is a photo of us, which I think was taken in 2019, where we have our annual team camp in Okinawa. The place is Shuri Castle, which is unfortunately not long after this visit. It was burned in fire, I think, in October 2019. And this is also our last team camp before the pandemic start. And here, this is the OTP API, the services, the API services that we have just released, not a few months, 2 months ago. And we love Python. Most of our stack are using Python and Django. In the past 10 years, we have wrote numerous articles related to Python, and feel free to check them at our blog. So what's in this talk? Okay, we go through why we built a custom task queue, why we decided to use PostgreSQL, and then we look into what is multi-tenant task queue. Then we look into basic implementation in Python, and probably a demo after that, if permitted. And then we can have some Q&A sessions. So why build a custom task queue? Back in 2010, we launched our first services called Easy SMS, where one of the features was to allow user to send SMS up to 1,000 recipients, either by entering the recipient list in the web form or uploading CSV files containing the recipient list. So in the initial version, we did it in naive way by processing that directly when user upload a file. It's not taking too long before we realize that it's not going to work, because sending SMS is a slow process, and on top of that, we have to do other things like determine the route to send based on few conditions, checking if user has enough credits. And so it takes a long time, and very often the requests get timed out, and the whole process will break half the way. So we realized we have to store the task in queue first and processing it later on. This was when we built our first task queue implementation using MySQL. But I'm not going into details though, as today's topic is about Postgres instead, right? So why build custom task queue? So it's hard to find task queue with multi-tenant support, and at the same time require low maintenance overhead, at least back in 2010. So things might have changed now. I not doing another extensive research since the last time we are working on this Postgres implementation. Okay, next, and why we decided to use Postgres for our task queue implementation. We are using SQS before implementing our task queue with Postgres, and one pain point is inspecting what's in the queue. SQS doesn't provide specific API for that. To inspect tasks in queue, we have to pull it out using the same API as the worker, which means we have to compete with the workers. So we have to try a few times before we manage to get the job, or else we have to stop all workers first if we want to really look into the problematic task. So using Postgres, queue inspection, for example, can use common and established tools, which is the SQL. Right? We just go to the SQL console and then run the SQL query to check the problematic task. Then we have persistency for free. Some task queue, you have to, sometimes it has to specifically configure it if you want your task to be persisted to this, or else they will just manage the task in memory. But Postgres, as we know, is a database, and then once we add the task to the database, and it's there. We will also have automatic processing with respect to other database work, which is also a bonus. And yeah, finally, the custom requirement, which the topic of today, which is to have the multi-tenant support. So this is, as mentioned before, we use SQS before we move to Postgres. And one of the main problems we have at that time is to ensure each user's task being processed in fairly manner. So this is what we mean by having the multi-tenant support. So for example, if user A add 1,000 tasks and user B add one task at the same time, then task for user B should be processed immediately instead of waiting for A to finish, which is ridiculous, right? So this is hard to do in SQS, as we don't know which task each worker will get. We can create a separate queue for each user, but this will add more maintenance work to provision the queue for each new user and delete it when the user is no longer with us. So we searched around until we found the blog post from holistic.io, which shown here in the slides. So we look into the mechanism, the implementation approach explained in the blog, and it looks simple enough. So we decided to give it a try. So originally, using database for task queue is a bit tricky because of the locking process involved. When working on a task, you want to mark that task as unavailable, and to avoid other work. Also, doing the same operation, you have to lock the row. The problem with locking the row is that the other worker that fetching the same task will wait for the lock to be released. So this consequently causing all workers to work in serial instead of concurrently. So there are several tricks to work around these locking issues, such as using Postgres advisory logs, or in other database such as MySQL using update technique and check for the affected rows. But in Postgres 9.5, introduced one interesting feature called skip lock. It solved the exact problem we described above. So when doing select for update skip lock, Postgres no longer wait for the lock on the row to be released. Instead, it just skip to the next row. So with this in place, we now have all the ingredients we need to build our task queue using Postgres. So there are two approaches to implement the queue worker, which will be fetching the task from the database and process it. The first one is using Postgres built-in notification channel, which is they call it the listen and notify function. So Postgres allow us to create an arbitrary channels where client can listen or subscribe. When we add new tasks, we can post message to the channel telling a new task has been inserted. The workers which listen to the channel then can execute query to fetch the newly added task. And then in second approach, we simply run an endless loop that keep checking for new tasks. This obviously will add an extra overhead, as each workers will keep issuing select query to the database. But in practice, it's actually not a big deal. We never reached the max connection limit so far yet. This approach is also simpler, and for this reason, we decided to go with this approach. So here are a couple of third-party Python libraries we use. I decided to try using Pewee for this implementation. It's an ORM. The one that we are using in production currently just using plain Python DB API, but I've been thinking about using Pewee for quite some time, so why not give it a try this time? As for Pebble, originally we just used multi-processing from the standard lib to spawn process for the worker. But it turned out managing spawn process is not as straightforward as we thought. Handling process termination in graceful way is tricky, and then the process coordination. So we decided to use Pebble instead on top of multi-processing. So here is the basic structure of the worker app. Quite simple. It's just two data model with 7 functions. We'll get into each of one of them next. The original implementation from Holistic, they are using Ruby, and they couple it with another task queue called Sidekick to actually dispatch and run the task. The advantage of this approach is that they have better job control provided by Sidekick. However, we decided not to use another task queue to dispatch and execute the task, but implement everything in our Python code. So here is the main data model, which is the task that we hold all the task information. The function field here represent the unit of task, which simply a function that will execute in order to complete the task. Using function as a unit of task is a very common approach, and we can see this in other task queues such as salary. So this model is we define it using Pewee as the ORM. Pewee actually quite powerful and comprehensive in terms of SQL construct that it can support. They have support for JSON-B, arbitrary SQL function, CTE, window function, etc. Something that many ORM would skip and just offer you to drop into raw SQL if you need them. So, and then this is the second model that we use to define how many slots every user have. So the slots here represent the number of concurrent tasks they can run. Having this record actually optional when we want to define limitation for a specific user that different from the default. The original implementation by Holistic doesn't have default. So for every user, you need to define their slot number here. We found this cumbersome because in our use case, user come and go, and it will require some provisioning tasks every time we have new user registered. So we added a default slots number in the query, as we'll see next. Okay, so this is the meat of our task queue implementation. It's an SQL query to fetch one task from the database to be executed. Very simple query, and it's actually fit in this slide. We don't remove anything here, and it's easy to understand. I think this is the most important thing. Solution that you can understand is much easier to extend when you need it and easier to troubleshoot. So we use two CTEs here in order to eliminate first user that already maxed out their slots. This is how we achieve the fair distribution in multi-tenant setup. We can see the effect in demo shortly. Okay, and here's the equivalent query turned into what Python code using PW. So I have to admit it took quite some time for me to port the plain SQL query into this PW construct, but I think the result is not that bad. PW try to stay close to SQL as much possible, and as you can see here, most of the the method function provided map quite close to SQL. And so here is the add task function where we'll use to add tasks to the queue. I have removed some stuff like error checking and logging here to fit in this slide, but this is essentially what's needed. I wish the actual code can be this simpler as well. I mean, in Elise and Elan, they have what they call code only the happy path and let it crash. So I wish we can have the same thing in Python. Yeah, and this is the worker, which actually here is, you can see here, no, not here. So we are calling the another. So here we spawn the we start the pebble for the multi-processing part, and then which we call the process task, which will do the actual loop. So here is the main where we endless do the endless loop to keep fetching the next task from the database. Right? We got one task and then we pass it to Pebble, which will spawn a process. Not spawn a process, but we'll pass the function to the process pool, which will execute the task. And then here we have some stats, which is a basic SQL that we pull out. We used to pull out some information about the queue, and this also related to what I mentioned before, where we can use existing tools like to such as to show some stats of the queue. Right? And yeah, the full code is available at GitHub. You can go there if you want to see or try it yourself, the implementation. And yeah, let's look into some demo. And I'm not sure whether you can see these videos. I tried. Okay. Is that audio available from this video, Miss Nita? I'm not sure whether there's an audio or not.
So here we have this. So on the first screen, here we have instead just run some basic SQL.
Maybe too low.
Sorry. Is there an audio from the video or no audio?
Yes, but yes, I can hear, but it's too low.
Yeah. Okay.
Yes.
Maybe. What about this?
It's running. On the second screen here, where we will run our worker.
Okay.
And
Maybe the audio. There's a problem with the audio, so I just go through.
Enough.
Okay. Uh, so here this is we have three screens here. One to show the stats, and then this is where we run the workers. And then you can see here from the stats we have okay, it's not running yet. It's not running. So first we will run with six workers, and then we can see how the numbers here change.
on the third screen, we'll do some. So let's try running with just six workers first. You can see on the left, on the stats, the progression of the cloud. We can start in here.
Okay, and this is when we have start the workers, and then we can see it start processing here. We can see here is the task that currently running. Uh, the most important thing here we want to look here is that we want to make sure that uh, each user only has three concurrent tasks running. You can see from here. You can make it larger. Right. So we can see here, and then except for one user, this user Lucy, for example, we set their maximum slot to 10. So that's why you can see here, this Lucy user has 10 concurrent tasks. Okay, we run again.
And we go to the third screen where we want to add new tasks. Okay, let's see. We want to add for this ID, okay, one task.
So in another screen here, we want to add new tasks to the queue. So what we want to see here is that when we add this task, so we add this task just one task, and we still have, for example, Lucy still have 102 tasks, Lina have 15, Kamal have 12. So we want to make sure that when we add tasks for Ali here, it's being processed immediately instead of having to wait the other task to finish. So that's what we mean by having the multi-tenant the support.
What we want to see from here is that Ali task. You can see here, Ali task is already been processed.
So you can see that after we add the task to the queue, it's immediately processed. So it doesn't have to wait for the other task to complete.
Just immediately.
Okay.
It's done. Task one is done. So it doesn't see. Okay, another thing here is that delay here. So the number. And so next.
Okay. So all the tasks is done now, and the other things that we want to look for our queue is that the max delay here. So we can see here the number of max delay is little bit high. So we have tasks that been delayed for 3 minutes, for example, and there's 4 minutes tasks that got delayed. So the next thing is we want to see if we increase the number of workers, whether that will change the delay.
This time we will run with 12 workers.
So okay, here we run the workers with 12 workers, and
But nothing to access. So we go to this screen. So let's make it just a bit so we just reset the task status so that it will be processed again. So here, let's process again.
Okay, I'll just skip this and go to the end.
Be extended the more that it get retried.
Okay, and here we can see some difference in the max delay. So now with 12 workers, now the delay, the numbers of delays is being reduced significantly. So we see that most of the tasks has just few seconds delay, and only one task that still have 1 minute delay. So yeah, so I think this is for the demo, and we get back to our slides. And yeah, I think that's all. And maybe we can go into some question and answers. If anyone want to have a questions, then feel free to ask. Okay, thank you. Okay, in case there is no question, then maybe we can go back a little bit into the uh, the details of the implementation, where you can see here. Hold on, not to show. Okay, go back to the demo.
So maybe we start with just
Okay, there's one thing here that maybe I can highlight here. You can see this the logs in red here. So this is showing the task that's actually failed, and the way that we design this is that the failed task will get retry again later. But the problem is that we can't retry this immediately, right? Because if we do that, then the queue will just start, because it will keep processing the same task again and again. So we have to implement something called exponential backoff retry, where the retry time will be extended the more that it get retry. So maybe the first time it get retry, we will retry again in another 2 seconds, and then the next retry will be in another 4 seconds, 16 seconds, and so on. So this help keeping the queues from being monopolized by the same task that keep failing again and again, right? And here also, we in the actual deployment, we have to add some monitoring here to check for the tasks that keep failing. So then we have to decide whether we have to look into what's really the problem. So here it's saying that it's failed to getting a function PGSQL do something. So maybe the function doesn't exist, or maybe there is a failure and exception when running the function. So we have to look into that and decide what to do next, right? And usually for our deployment, what we are using is we just has a cron job that running to check a task that taking too long to finish. And if we look back into this, sorry, uh, it's the code. Oh, I'm sorry. I think I missed one. The process task, right? Oh, where is it? I missed one. The process task. That's right. So let's GitHub. This one. This is actually quite important actually, because this is the main function. So here we see the process task. Not the process task. This task done. Okay, here this is actually some control that so for every task that we spawn using Pebble, we will here you can see here we add then we attach this task done function that will call when the task is finished executing. And it is here that we can do some handling, or if the task is fail. For example, the common use case is when the task get time out. Depends on the timeout value that we set, and then if it's more than that, then this function will be invoked, and then we can do something like logging or updating the task to fail status so that it get retried again. Okay, yeah, I think that's the whole presentation that I have today.
Okay, we thank you for your presentation. We have two questions here. I will show it to you.
How is it compared to Redis queue? I'm not sure how I can answer the question. We can implement something similar using Redis queue. I think I'm quite sure of that, but I'm not sure how to implement that. We never look into try to implement the same multi-tenant support using Redis, because we already using Postgres. We much more familiar with Postgres, and then the approach that we try using Postgres is work quite well for us. So we didn't actually try to implement this using Redis. That can answer.
Okay, then we have second question.
How to make sure we don't execute the same task concurrently? Yes. So this is what's that I mentioned in the slide. Why the skip log features from Postgres is really important here, because when you fetch task to be processed, you should mark the task with some status, like for example running, and then when you fetching the task, you make sure that you are not fetching the task that already running. And in order to do to update the status, you have to lock the row, and that's the problem if you're using database, because if you lock the row, the other worker that trying to fetch the task, they will wait for the log to be released. So this means that even if you have 10 workers, all the 10 workers then will wait for the log instead of just working on another task. So with skip log, when you lock the row and then the other workers try to fetch the task, it bump into this task that's currently locked, then it just skip to the next task. And that's how you avoid multiple workers working on the same task. This is from on the queue side, but on the task side itself, you still need to take another measure there, because this depends on the nature of task itself, and then so it's not a generic. But on the task itself, you must implement some mechanism, for example, checking whether this task has already been processed or not, because you also keep the task status on the application side, right? So firstly, we are talking about preventing running two tasks on the queue side, but we also have to take some measure on the task side. Yeah.
Thank you. We have the question here. It's a long question, I think.
As MySQL broker, which resource that's consumed a lot by PostgreSQL broker, memory or disk, and how to tackle the issue? Okay, good question. So far we have been running this a few years now. So first we look for the connection. So that's our first concern. But turn out that the number of connection is quite minimal. We never reach more than 50% connection, even on the busiest day. When sending 100,000 of message, right? Means the connection is still less than 50%. Memory also is very minimal. I think never reach 50% as well. So yeah, the disk is the problem, because when we keep adding tasks, right, and this is the general problem when using database as message queue, because as the tasks get increase, the table get larger, and then your query will get slower and slower. So first, as with the general what rule when using database, make sure you have proper index. That's one thing, right? You have to index the name, the message ID, for example, the class ID, that must be indexed. And secondly, you have to have some purging routine. So we run our purging routine like every month. So every month we delete all the tasks that older than 60 days, I think. It's depending on also some legal requirements for us. So I'm not sure about that, but we have to delete the older tasks. Otherwise, the table will grow larger and larger, and then we keep slowing the query. Yeah.
Okay, thank you.
Yeah.
And we have fourth question. Wait.
Okay, how is it differentiate with tools like Celery? Okay, I saw that most of functional are identical to Celery. So, as the topics in this talk is the concern here is on the multi-tenant support and distributing the tasks in fairly manner across users. So this is one things that lacking in many of task queue implementation, including Celery. If you don't need uh, for this use case, for this particular use case, the multi-tenant support, then definitely you just use Celery. Yeah, it much easier. It's already complete. Right, there's so many tools there. You can just go with Celery or any other tools. But if you're looking for something that has support for multi-tenant and in distributing tasks in fairly manner, then you can consider using this Postgres implementation.
Okay. Um, we have this question.
Seems that Celery could be integrated with Postgres through SQL Alchemy. Have you tried that solution? Okay. Yes, I think I remember now that using Celery, there is also I think the database broker. I'm not sure how hard I'm not looking into details on whether it's possible or feasible to implement this what the multi-tenant support using the Postgres broker in Celery. So yeah, that's all that I can say. Probably possible. Maybe someone already working on it. I don't know.
We don't have any questions for now. Okay, Mas Kam, Can you? Okay, we have message from co-moderator. Your repository GitHub maybe still private.
Oh, really? Oh, I'm sorry. I'm really sorry. Yeah. I okay. Make it public. Okay, it's supposed to be public. Okay. More questions?
Yeah. And can you share your video demo
Can what?
on your
I
talk?
miss you. I miss the voice, the audio.
Can you share? Can you share video
Oh, the demo.
demo?
Sure.
Yes.
I'll put.
Well,
You can follow. I think you can follow the link, the presentation link. Then I will put it at
uh-huh.
the same page on our website. The video.
Okay, on link presentation, yeah.
Yeah.
Well, we don't have any questions here.
Okay.
Okay. Do you have message for your viewers who's watching you now?
Okay. Message. Not sure. We
Yes.
still have time.
Maybe you want to say hi. Yes, still have time. You want to say
Oh.
hi for them or something?
Okay. So yeah. Thank you so much for having me here. It's and it's quite a shame that we can't actually meet in person, go to Indonesia. But I think I keep following the development means with the Python community in Indonesia, and I think the Python community in Indonesia is very, how to say, very vibrant, engaging, right? They and also quite large, and I think they never miss doing PyCon every year. Uh, I missed the PyCon last year. Means that's the problem with online conference. I thought that when conference being held online, then I can join all of them because it's easy, right? We don't have to go anywhere. But it turns out that when it's online, I keep missing them. Right? It's like what yesterday is PyCon Indonesia. I already miss it. So I keep missing
Yeah.
the conference. But thankfully this year I know it early, so that's why I try to take a chance and try to submit the CFP, and luckily got accepted. So it's very what exciting to get involved with the Python community in Indonesia as well. And also hopefully next year we will be able to do our PyCon Malaysia, PyCon Month in physical. So we are welcoming all of you to come to Malaysia, and then we can meet in person for another PyCon.
Okay, guys. You can give your words too for Mr. Kamal Mustafa.
Yeah.
Give your words to the speaker. You can see on your screen. Give words to the speakers. There's a link to fill the form. Don't forget to choose Kamal Mustafa as speaker. Okay. Uh, I think that's enough. No more questions here. It's nice to meet you on virtual Python Conference Indonesia.
Yeah. Thank you.
Thank you for sharing with us, and see you on next time mungkin. Maybe. Oh, you can speak Indonesian or not?
I can understand Indonesia, but to speak it,
Okay, selamat siang.
ya terima kasih semua.
Terima kasih sama-sama. Okay, that's the end of talk with Mr. Kamal Mustafa. Don't forget to give votes to the speaker. You can see the link on your screen. Don't forget to choose Kamal Mustafa as your speaker, and you can give your votes on the box. Okay. See ya on the next talk, and thank you. Bye bye.